So now let's go and investigate joins a little bit more carefully. So what would happen if you have joins? In other words, you put multiple tables into a query that are not related with any common attribute. Then you get what's called an outer join, which basically becomes what's called in computer science terms a Cartesian product. It contains all possible combinations of rows, which is typically not at all what you want, and the result is simply ridiculous. It has no meaning for you. Let's go take a look at that, see what that would look like. Let's create a query where we're going to bring in orders and products. Notice there's no line between the two. So then we said, well, I want to figure out the order date and on what date the product was ordered. So we're going to put down a product name. And you run it. And you get a ridiculous number of rows. Down here, actually, 1,287 rows. So an order date of 4/15 for Pentium 3, order 15 for see, look what it does. It looks at every possible date and combines it with every possible product. Then it does the same thing for the next date. See, Pentium 3 and 418, Pentium 2 and 418, Pentium 2 on 415. And it keeps going, makes every possible combination, which is not at all what you want. So you can't have queries that contain tables that are not somehow related. You have to make sure you put tables in between that form a relationship. In this case, that would be line items. Notice now I have full relationships. I run it now, I get a very different result. I actually get the dates on which particular products were ordered. And notice that the output only has 84 rows. I don't get all the rows that are nonsensical. So very important, make sure that there's always a connection between your tables when you make them part of a join. Here's an example of this time doing contacts and products. Unrelated tables, get every possible combination. If you want to know who ordered which products, you need a query that includes all the tables connecting contacts with products. And that would be what the query would look like. So to do that, it would look like this. Let's create the query. Again, should stop the video and try this yourself. So contacts and products are not linked. If I bring in orders, orders are linked to contacts, but orders are not linked to products. They're linked through line items. I got to bring in line items. So now I can figure out the contact ID, first name, and last name of the customer who ordered some products. And if I want to figure out what product they ordered, I can bring that down from this table. So I know that, for example, Nicholas Cologne ordered 3 things from us. He ordered DVD discs, floppy disks, and Norton antivirus. I know, for example, that Neil Goodman ordered 4 things from us, and so on. Now, when you start building more complex queries, you might want to filter, meaning you might only want to select certain rows. One way to make sure that certain fields meet criteria is to use the criteria field and then change that total clause to a where clause. For example, only listing the line items where the quantity is more than 2, where basically somebody ordered more than 1 of that particular item, is done like this. Let's go try it out. Bring in line items, line item ID, and the quantity. I run it. Right now I get everything. But if I only want the ones that equal to 2, one way to do this is just simply typing greater than 2 right here. That also works. But now both show up, quantity and line item, or what it can do is it can use the totals, and then here select the where clause. By the way, it automatically becomes unchecked. So now you only get the line items. You can't even check it. It will not. You cannot bring that as part of the query. You're going to get an error for that. So where clause is always a field that is used in the construction of a query, is part of the execution of the query, is an applied filter, but does not show up in the result. Here's another example. List the order dates where the quantity of an item ordered was at least 2. And each date should only appear once in the result. So go stop the video, try this out before I show you the solution. So here's what the solution looks like. So it says order dates. We know we need to get to orders. Where the quantity ordered was more than 2, well, that doesn't tell us anything in here about the quantity ordered. That's in line items. So I know the quantity ordered is in here. And I'm supposed to give you the order date of all the line items where the quantity, of all the orders when line item had a quantity of more than 2. So bring that in and I run it. But I have duplicate dates. So I don't want duplicate dates. I need to use the group by, and I only want those where it's greater than or at least 2. I think it's greater than or equal to 2. I run that. I get only those that are greater than or equal to 2. But I still get duplicate dates. See, for example, right here. Removing those, I can simply do a group by. But the group by doesn't work because the rows are not exactly alike. So I still get some duplicates here, see? Because those rows are not alike. The way to fix this is to make, you can't just simply uncheck this, but to turn this into a where clause, a true filter. Whoops. So now it's not part of the result, it's only part of the filter. And I'm only grouping by order date. So now I get a unique set of dates of those orders that included a line item with a quantity of at least 2. So somebody may have ordered, let's say, 2 floppy disks, or 2 Norton antivirus, or 10 DVD monitors, or DVD disks, or monitors, or whatever they've ordered. So here's the way to solve this problem. If you used the group by, it wouldn't have worked, as we saw, because you would have had non-equal rows. Now, to learn how to use the different selection criteria, here is the translation of English into the algebraic term. For example, at least 2 would mean greater than or equal to 2, or less than 5 would be a less than 5. So make sure that you have the correct understanding of what the translation is. So if I say, bring us those queries where you have at most 5 items, at most means less than or equal to the upper number. So make sure you know how to translate from an English narrative into the appropriate algebraic term. Now, sometimes when we output results, we might want to change the output attribute name so that it becomes more meaningful. So for example, if we output last name and we might want to change one of the other fields to something else, we can do that by renaming it with a colon. For example, to show you that query, we'll have the contacts here. I'm going to output the first name and the last name. I run it, and by default it says first name and last name, the name of the column. But I can change that, for example, instead of calling it last name, I call it surname, because maybe that's more meaningful for your particular business domain. I can also make these fields a little bit longer to show you everything. Now notice what happens. I get first name and surname. It shows me the surname name instead of last name because I renamed it. By the way, you can also click the drop down here and only select certains. That's an applied filter to the result, not the query itself. This does not become part of the query. We've only seen filters so far that are part of the query. All right? So that's how you rename fields. You can also create calculated fields. So let's try that out, where we can list the extended price for each line item. So let's do that query. So bring in the line item. For each line item, we can bring out the quantity ordered and the unit price. Heck, we could even bring in products, so we know what the product name was, right? We'll bring in products and print out the product name right here. So we know that line item 1 was DVD discs. They ordered 1 of that for $23. Line item 2 was HD floppy disks, quantity 4 for $9.99. We don't know what order they belong to. We just know that at some point in time, some order contained a line item for that quantity and that price. but we want to know often the extended price to be able to put into reports and use it for filters. So to do that, I have to do a calculation. To do the calculation, I have to type in brackets, square brackets. Very important to square brackets. Quantity, bracket close, times unit price. Here it is. Let me run it now. Notice it shows up as EXPR1, expression 1. Can actually go ahead and change that to something like extended price, EXT price. I'm using the renaming mechanism now. Very important, make sure you don't misspell them, and make sure that you put brackets, square brackets around them. See, extended price. Now, what would happen if you misspelled? You had fast fingers and you typed in quantity instead of quantity. Watch what happens. You get a dialog. It asks you to enter parameter value. Later on, we're going to take advantage of that feature, but right now, if you see a dialog popping up like this, it means you misspelled this field right here. The spelling has to be exact as it is in the table. So in the table, it's called quantity. You better call it quantity down here. Now it runs, you get the extended price. Now, once we know how to do calculations, now we can do aggregation. Aggregation means we combine things. We do calculations and combine things. They work within either group bys or an entire table, depending whether you have a group by clause as part of your query or not. Now, Access supports a number of different aggregation functions. Counting, we just count how many rows there is part of the result. Summing, adding, averaging, minimum, maximum, and standard deviation. Now, we're going to take advantage of many of them, particularly the first 5. We're not going to make so much use of standard deviation, although they can be useful for certain statistical calculations. So here's an example of finding the total for each order. In other words, the sum of the extended prices of each line item. So let's do that query. So this time around, I'm also going to bring in orders, and I'm going to put out the order ID along with all of this. So let me run that, and I'm going to get this going here. So order number 1 consisted of 3 line items. Line item ID 1, 2, and 3. See all order number 1. Here are the quantities, unit price, and extended prices. Now, here's what I want to do. I want to basically sum these things up. So what I need to do is I need to collapse them into a single group. Now, of course, I can't collapse because these columns here are different. So what I got to do is, first of all, I got to get rid of them in my query. So I get line item ID, product name, quantity, and unit price, get rid of them. And I'm only stuck with or left with the extended price. Same order ID, see? Same order IDs. So here's what I'm going to do. I'm going to do a group by. Now, of course, if a group by, it's not going to work because these things are not grouping. But what I'm going to do is, watch what I'm going to do. Instead of changing this to group by, I'm going to change it to sum. This will now take the order IDs and group them. And then within each group, it takes the extended prices and sums them up. So now it took, for order number 1, all 3 extended prices and added them up. And it comes out to 178.91. Of course, the column doesn't make any sense anymore. It should be extended price. It should not probably be order total. I run it. And that's it. This is a very important query. The key is that you can use that to add things up. And by the way, also filter to only get those that are greater than 1,000. So this shows you all the large orders. All the orders larger than 1,000. So this is aggregation. By the way, this query right here on how to calculate the total of an order, very important. Keep it in mind. You will need it a lot. So now this is the end of part 2. Go on to part 3.